So I'm the chief executive and founder of Smartlogic. I had a lesson this morning in the keynote about what it's like to be an entrepreneur. 6 new things to take away, partly because they're quite often the criticisms the rest of my team give me, because I clearly am not based in reality. So we're going to talk about assisted intelligence. I will do very little talking about Smartlogic. I hope to do quite a lot of interaction with the audience. I have a couple of fun and games exercises. Do not worry, it will not put you on the spot. If you want a synopsis of this discussion, the New York Times yesterday, artificial intelligence hits the barrier of meaning. We're in knowledge management. If we're in information and data science, then that's quite a good summary. I only picked it up this morning, which is why it's not in my slideshow, but quite useful, I think. Right, click, next. Okay, so what's the purpose of this presentation? So Smartlogic, which I started in 2006, very specifically we're in the semantic AI space. And I'm going to go into what is AI. There's quite a lot of hype. There's quite a lot of width in definition. I can show you where we are specialists, and I can very clearly explain, as I do to my customers, where we're not specialists and we don't know a lot. But I do know how we augment, I know how we use it, and I know how we augment it in other places. All right? So I want to show you very specifically how semantic classification, harmonization, and extraction augments and enriches AI projects and makes them deliver business value. All right? Because there is an interesting concept. The concept is that AI is great fun if you're in tech, but actually then the business takes a look at the results and says, I don't believe them. Right? So we really want to look at why that happens and what we can do about it to make that different. And I want to show, by going through this presentation, that we're all knowledge professionals in this room, or we're here to learn about it, or we're here to, it's our career, or it's some reason that you came to this conference. You're not here to, learn about how to lay swimming pools. So given that that is the case, how does that affect us? What is it? What's the relevance to data and information science? Okay. I have a couple of validation, because some people don't know who Smartlogic are and some people do. But here are my validations. I know very little about the subject that I'm going to talk about. I'm the CEO of a business. That means I talk a lot. I persuade. But I do know that my customers are the thing I'm most proud of, and these are some of our customers. We've done about 350 KM projects since 2006. Most of our customers are Fortune 1000, Global 2000 enterprises. Our team is here at a stand. We have very good customers and very good partners. Okay, and then the last credential is we're a leader of Smartlogic on the Gartner Metadata Management Quadrant. We're up there in the top right. We're the smallest person in the leadership quadrant on that list in terms of company size. Apparently, we are better at executing than IBM, Oracle, and SAP. Right? Why? I think it comes back to focus. We really understand metadata. We really understand semantic AI. We really understand the projects that our customers are getting into, and I'm just going to share one with you after we've had some fun. Interestingly, we're also a niche in insight engines, which is a relief, because metadata is what we do. Metadata is what powers insight. But when we were in the visionary section, which was a year ago, everyone thought we were a search engine. We are not. We do not have a search engine. We work with everybody else on that side. They're all our partners to help get search become insightful. Right? So metadata drives insight, and that's another takeaway. So what is real? The promise is compelling. I think that's real. The ability to automate higher order work functions using digital rather than human labor at a fraction of the cost is one of the compelling reasons for everyone getting very excited about it. It's an automation, right? It's removing what you might refer to as repetitive human tasks and replacing them with computer workers who are better at repetition, right? And we'll come into that. It is a global disruptive force. You can only see. Now we've got politicians talking about it. We've got people trying to put it into their country's planning. McKinsey estimates that the adoption is going to affect a lot, particularly China, India, Japan, and the United States. It's 1.2 billion employees. It's 14.6 trillion in wages. That is hype, right? Hype for now. I'm not saying it's not hype in 2100, but it is definitely hype for now. So we're sort of a bit like at the beginning of the dot-com excitement. They weren't wrong. It's happened before. Railways were a fantastic investment, but there was also a crash. And it was only after the crash of the railways back in the 1800s did actually they build 4 times more track than they had before the crash. So it's coming, right? It's a hype, but it's coming. So what's real and what can we talk about? So the AI I'm going to talk about, you can see there's already a quite nice little division of, everything from robotics, planning, speech to text, text to speech, image recognition, text generation, natural language processing, and machine learning. Okay, we're going to focus. This is Smartlogic's capability. We are clearly not in deep learning. We leave that alone. It's and for good reason. There are lots of other nice people out there like Google and Microsoft who are doing a lot of open source deep learning. We can use it, but it's not our intellectual property. We won't go near it. There's billions of dollars being spent on that area. We're very good at machine learning in the sense of text mining and text and semantic analytics, and we're very good at natural language processing. That means being able to classify documents, extract facts in Japanese and French and English all at the same time, right? So we're doing what they call natural language processing, which is the ability to read and understand text. Okay, so that's our area of expertise. Okay? I'm not going to talk about anything else because I don't know anything about anything else. Right? That's my area. So we're going to have an exercise. We use a lot of AI in our software. So we have our NLP stack, which is a whole bunch of AI in its own right. We, in our text mining, we do a lot of machine learning. And because we do, we know its good points and its bad points. So I want to do a play exercise, okay? Using all of us here in this room. We will act both as the data and as the machine. Okay? And I want to bust a few myths. You just give the machine the data, it learns and then delivers useful insight. Right? So we're going to act as the data in the machine. After all, we've all got many different implicit data attributes. And we have an excellent machine processing unit inside our heads. And when you consider the role of AI is to provide insight through better analytics or improve efficiency, right? It helps if we, as the human workers, understand how the digital workers have to go about it. So this is the exercise. And what better way than process it ourselves? So don't worry, I'm not going to put you on the spot. We're just going to go about organizing our data. We're going to give the machine the data, you'll learn, and then you're going to deliver useful insight, all right, as the learning machine. So, exercise 1. Look around the room and write down how you would categorize or sort this entire room into logical piles and what insight you gain. Go on. Doesn't matter what you write, or put it in your head. This is fun, right? You come to events. How would you classify this room? It's quite tricky, isn't it? I bet you're asking, how should I sort this room? I mean, well, I don't have enough information to sort it. I've just given the machine the data, right? And I expect it to come up with something useful. That's what machine learning is all about. I would guess we're human, so there was already context, but gender might have come into it, maybe. Even that's a difficult concept at the moment. Hair color, maybe. Age, that's probably the normal things that most people do when they're humans, sitting in a group of other humans and looking around first thing. But equally, Shoe color. Anyone got, right? Handedness, left or right-handed. Whether we're wearing glasses. These are all data attributes. They're all valid data attributes. And we, the machines, how are we meant to sort these out, right? Without. So this illustrates that whether you're a human or a machine, we need some context, right, about the answers, about the questions we want answers to. Couldn't just give you to ask you to sort it out. You need context. Everyone needs context because there's too much data elsewhere, right? I hope that was useful. Did it make you smile or even think? So this is what Gartner says about metadata. It's useful. You can have a copy of the slides. I'll speed up. But the point is that metadata people think of as the management of its data and information assets to address use cases such as data governance. But it's important to note that this understanding of metadata goes far beyond just technical facets. It's used as a reference for business-oriented technical projects and builds the foundation for describing, inventorying, and understanding data for multiple use cases. So my first thing I would suggest to you is that metadata is the way one conveys context, which was what machines need in order to be able to gain insight. Right? Can't remember what my second one is. Okay. My second myth is we will quickly assemble the training set, then pour it into the machine, and we will deliver actionable intelligence. Everyone agree with that? Myth, fact, or fiction? Right? It's easy, isn't it? We'll get that training set together. We're going to lob it all together. We're going to ask our users. I'll have a training set for this. Right? I actually want you to, do we understand what it means to put together a training set to give context to a machine learning algorithm? Anyone tried to do it? Yeah. Easy, difficult? Yes. Yes. Easy and difficult. Yeah.
Simple at first, but deviously hard.
Deviously hard. Actually, it's not a single training set. That's the first thing. Everyone says, oh, I'll just get a training set together. It is a training set for every dimension, for every data type that you're interested in analyzing. And if it's data sets for every data type, because actually it's not one training set, it is three. Right? Sometimes it gets bundled together and it's called one, the training sets, but actually it's a training set followed by a validation set followed by a test set. Right? And you have to do one of those, three of those, for every single data type you want. It takes a lot. Think about this, and we're going to do an exercise, right? Machine learning, I'm going to read now, is basically the construction of mathematical algorithms that can learn from and make and predictions on data. Good. Mathematical algorithms. The training set is carefully compiled to set the machine or the construct. The validation set is used as a control to compare the output. All sounds pretty good. And the test set is used to test the data coming out of the validated set against data that's never seen before. And then at the end, you get a machine that is capable of learning, of learnt, and then outputting new stuff. Okay? So after we've done the training set, and then the validation set, and then put it through the test set, we now have business as usual. So as we already said, it is a lot of effort and a lot of hard work. So this is our next fun exercise, right? We are the trained machine, right? Because we've learnt, we've got context, we think. So we're going to take the easiest case, which is a one-dimensional classification. Remember, we were talking about mathematics. We're going to carry on talking about mathematics. Right? So here's the exercise. How would we split the room based on the color of the shirts worn today? I want gray and black in one grouping, and I want all other colors in the other classification. How would we do it? Right? How would we do it? Good. Right. It's easy, isn't it? Right. First thing is those not wearing a shirt, get up and leave the room. All right? Because now you've got a complete set. Okay, so you've got to get rid of the data that's not in the set. And then everyone wearing a shirt goes into one of two groups, right? One goes the black and the whites on one side, the colors on the other, okay? And so a one-dimensional classification, which is what we've basically done, is one-dimensional. It's a line, straight down the room, right? Or in mathematical terms, it's everyone on one side or data on the other. And that's the simplest classification you can get. Right? So when the machine is doing its mathematical algorithms, that's what it's doing. It is classifying or dividing. It's trying to separate data from one side to the other, okay? Now we're going to stop and think about it. Sarah's already ahead. We have to understand the concept of color. We've already understood what black and white is. And we have to understand the concept of shirt. But we have to do some semantic intervention at that point, because you might be a blouse, it could be a top. Does it or does it not include a turtleneck? Right? So even the concept of a shirt is being applied by our learned machines, us, into understanding what the data is, the context of the data. And then we have to understand the concept of color, right? Black and white is easy-ish, but you got it. Does it include gray or doesn't it? Right? This whole concept, if you want data to be veracious, you want data to be of high quality, we have to give it context, we have to give it authority, we have to give it, if you like, a standard, right? Now, black and white's easy, but what if we were doing purples on one side and reds on the other? Right? As your data gets really tight, when is purple purple and not red, and when is red red but not purple? Right? So what you're seeing is, just think about it. Hopefully this is a useful 45 minutes of your time to think about it. But if I'm a machine and I'm trying to learn data, put it into the training set, and it will be delivering actionable intelligence, I really need this grading of data, right? So maybe you can see how noisy the output comes as you actually increase the dimensions. So let's add some other data types. That basically is a one-dimensional sorting, but let's add some other ones into this model that we're all thinking about. Hairstyle. It's not clear. Let's add another data type. Shoe size. Right? This is now a three-dimensional model. Now I want, because I'm interested in the relationship between colored shirted humans with short hair and how this relates to size 7 shoes, right? How would we do that? Context and the mathematics to organize less than 7 size shoes with short hair, with colored shirts, not black, not white, not gray. That's not a line, right? That is a very interesting little shape, right? A multi-dimensional mathematical polynomial shape. That is the mathematics that is used in machine learning. And so you start to understand that even with 3, if you in your own mind can see yourselves trying to get a ribbon around this room, correct, short hair, move them all over there, colored shirts over there, shoe sizes, which we need to have an understanding of, measured down here, that getting that machine to understand all of that classification is multi-dimensional. Then you see why the more dimensions, the more noisy the result coming out of a machine. The mathematics is very hard, right? So our job is context. What it does is it reduces the number of dimensions in the machine. Why? Because if you are a knowledge person, you have written a taxonomy, you have an ontology, you have a controlled list, you might have a subject matter expert. You can get and type all of the data as it goes in. You say, it's a brand. I knew it was a brand. I've got a list of brands. I can type my data as a brand. Right? I don't have to spend all my maths time going, pour it into the machine and get it to do the work. Right? the role of knowledge professionals, the role of taxonomies, the role of ontologies in AI is actually to reduce the dimensionality of the mathematics and therefore decrease the noise of the mathematics, increase the value of the output of the machines, and they go hand in hand. Machines and humans work together, right? Humans providing the knowledge, the machines doing the reduced complex mathematics to keep the quality high. That's what we do. And that case study I'm going to show you is that. It is for this reason. So the first thing is, this is a lot of effort, right? It's a lot of time to put these training sets together. Why let's not spend the time putting the training sets together of the stuff we don't have typed, right? Because all the stuff that we do have typed, all the context we've got, we can get from elsewhere, right? And what's really interesting is that because we are talking mathematical algorithms in machine learning, we're talking about disintermediating the user from the data, because you have to put a mathematician in the middle, and therefore the users lose sight of the domain expertise. And the domain experts are everything, because the domain experts are who can describe what the real data is. Right? And every time you ask for another few maths graduates to help with the machine learning, and you're not calling up your business user, you're disintermediating the business, and so they don't trust the results. The real answer is, I would say, semantics, and because I'm Smartlogic, semaphore, but the answer is knowledge context from humans going into models to help reduce the dimensionality in order to get the machines to learn faster, better, and more voraciously. So the third myth I want to try on is machines are going to be autonomous decision makers soon. I don't think so, right? As you can see, the number of dimensions that increases, that's why they're very good at voice to text. It's excellent. You can teach the system the grammar. In our NLP, we know exactly how the written word is. We know it in all the languages. We teach the machine the grammar. It's got a whole long list of reference data that it can use, and it does great NLP. It's very good at finding exoplanets, because your machines have to have a nice and narrow focus, right? If you're going to keep the dimensionality low, as much content as possible, but a focused field of view for the problem is how they work. So yes, they can beat you at Go. Yes, they can find an exoplanet. Yes, they can drive, but not when it's snowy and rainy, when there's no markings on the road or on the dirt, right? Because it needs the full 100% context of the road markings, right? So that's all good and well, and that's useful, but why won't it work in the enterprise? Because enterprise, the business of decision asking is so wide. First, one day you want to know how many people died in an ambulance on the way to A&E, and then tomorrow you want to know how many people died on the way in an ambulance on the way to A&E when there was a paramedic on board, and then you need to know, well, actually, I'm not interested in the A&E and the death rates there. I now want to understand about who's been taking the fraud out of my co-pays, and I'm now starting to do some investigation over here. So the data, right, inside enterprises is very, very, very much more wide. It is not a narrow beam data. It's very wide data. Now, we can get an expert who understands about fraud, and we can get an expert who understands about to put the domain together. Then we can start to think about how we use our AI. But it's humans plus machines. Okay. So I don't believe today it's mature enough to provide full autonomous decision support. I think it can automate the next level of repetitive work, right? And its cost and efficiency perspective is simple. I think the thing that's being missed out of this next generation of repetitive work is that it's actually very high quality. If we start taking the machines have got to a point where with human governance, they're actually higher quality than humans doing repetitive work. For example, keying in data out of a contract. Right? Data veracity is important, and semantic AI supports the automation of these sorts of tasks. So to summarize this part, before I move on to the case study, the fewer the dimensions in the maths, the better. Subject matter expertise is paramount. Humans provide the knowledge, the context, and the meaning. People in this room are really important in that angle, right? Because you know how to codify knowledge into ontologies and taxonomies in a way that most other people don't know how to do properly, right? But that is how you impose the meaning into the machine. It is an interplay between human and machine. It plays to each strength. We have the creatives, they've got the repetitives, and metadata is how you encode context for the machine. Right? Take that view, use semantics to do all the metadata, ontologies, NLP, all that stuff done. Add it to your machine learning experiences. Add another piece of human expertise called knowledge management. You'll get quite good results. The business will understand it because you've helped the business encode it. Right? And then this is maybe useful, the AI business continuum. I talk about the business continuum because it is about business value. We start off with automated intelligence, assisted intelligence, augmented intelligence, and artificial or autonomous intelligence. I think from about the 2010s, we've got about as far as the assisted. I think the next decade is maybe getting us over there, right? But I do not believe we're getting to be replaced by human beings in our entirety as autonomous decision support vehicles anytime soon, right? Hence, I quoted the New York Times, hits the buffer of meaning. So here's a case study. How long have I got? 15 minutes? Yep. I should really call my colleague up here who's doing the case study, but I'm not going to do that. He said, if you do that, I will leave. But if you do like anything that you've heard today, we actually are having a social for all our customers. So if you're bona fidely interested in the Smartlogic concept, you can come to our social. It's tomorrow night. It's 5:30. Just come to our stand and no, before I get into the, right? If you're a competitor, you know, you're welcome to. We're better than you. But this is all about, it's an ongoing project, so I'm not really going to, I'm not going to go into, I'm not going to name names. I hope you understand that. If you become my customer, you don't want me to tell you about what you're doing either. They believe this gives them significant competitive advantage over the old way of working. But it is so simple, it's really easy, a case study. It's about logistics and transportation in life sciences. So we start off with products being made in a factory, right? We're in life sciences. Right? It's interesting stuff that they make, right? We have to move it to other places around the world. Okay? In order to move really interesting stuff, we have to put it in containers. And then we have to ship it, transport it in lorries, put it into airplanes to other places. Now, it's quite interesting if you know about the transportation of drugs. It's a regulatory environment. So every country you move it into has a different set of regulations. Highly temperature sensitive. Right? If your opiate is sitting in a vial in a container in the baking sun and that container is not refrigerated, it goes off. Right? So clearly, you can't let that happen, and you want to know if it has happened. Right? Stuff like that. So difficult problem because we have our standard operating procedures about how we're going to take that drug, whatever it is, package it up into a specific package, right? Put inside the insert into the package that is actually specific to a specific country. We're going to define what we call a lane, which is all about the whole journey that this is a whole journey, all the data associated with the journey of that package in that container, in that airplane, all the way to that destination. right? Such that we have a document, which is a compliance document as to what happened to that package, where it went, who signed it off, what happened, what transport it was, what was the shipper, who was that thing, what were the temperatures around that, all of which goes into that document. Right? We have regulations from where we start. We have regulations to deal with where it ends up in 2 countries, and a third regulation maybe in a third country. So you've got this really interesting, right, just simple concept of moving a packet of aspirin, from here to there. And interestingly, the data all feeds into this thing, this document, which is a digital document, but it is called a lane in their case. Right? So that document, not data, document is the data. Right? And there are so many practices like this. The contract that a bank signs for your mortgage is the data comes out of the contract, not the other way around. Right? When you're doing when you're exporting a F-15 fighter jet, right? The export contract is the root document that sets the tone for the regulation, not the data that gets coded out of the document and put into the systems. Right? If you go to court, you get out the contract. You do not get out the database. Right? So it's very obvious that contracts, documents are real, for compliance-based systems, are a very important thing. Hence, the ability to semantically extract data out of documents is very important, right? Because it drives a lot of business processes. Anyway, what we've got is the idea of data coming out of the Internet of Things in the aeroplane. You've got data coming out of the containers. You've got temperature sensors. You've got all that sort of stuff. And you've also got data that actually today, and this is where we get into why the AI replacement, you've got to take the lane document, and a human, in the old way of working, is coding up the data out of the document into the database. Right? That is a repetitive task that is very expensive, and humans are not very good at doing it. Right? They go to lunch. They have hangovers. Right? Right? They get bored. Right? They get very, very bored. The consistency and quality of tagging up documents manually is very low compared to a properly trained artificial intelligence semantic machine. Right? But if we take away and look at the data challenge, take away the environment, basically, we've got data, right? Data coming out of IoTs, data coming out of documents, data coming out of databases. But actually, in order to get the whole picture of how did that aspirin packet move from here to there, and did it break any temperature guidelines, we've actually got to unify the data, right? So the data challenge is firstly a semantic challenge of getting we can get all the data into a data hub, but we can't get the data out of the lane document because we need to code it up, right? Human or machine, right? Humans set the rules, the machine does the extraction, right? Because we need analytics. So that's the first challenge, the semantic extraction, the fact extraction of data out of a document that can be relied upon and aggregated and put into alongside data. Sometimes people ask me why I started Smartlogic in the first place, and I tell you what the founding concept was. You can't ask a PDF a question. Right? That was why we began it, Matthew, my CTO, and I. You can ask a database a question, but you can't ask a PDF a question. You have to get a human to go and code up all this data out of that damn document. Right? Now, and semantic AI allows you to ask a PDF a question. We've put semaphore on top of the lane document, and lo and behold, this is what one looks like. We take the bits out of the document and fill it up, right, into a database. Right? That's a whole load of AI stuff, and a whole load of ontology taxonomy stuff, right? And quite a lot of information science stuff, because we need to codify, give the AI some context as to what to look for in the document in order to know that the data is coming out of that. Right? So we use a lot of different things. We use text mining, we do document fingerprinting, we've got anchors that allow us, but we have this whole concept called fact extraction, which literally allows you to ask a PDF a question, right? And it understands what data it's got in that PDF. And it goes through and and it's clever. And you're welcome to come and have a look at it or come and talk to me at a drink at our social. So the fact extraction challenge is quite interesting in that we've got the lanes, we've got the data, we've got form data, where it came from, we've got destination company, you'll see in that. But actually, the data challenge is more than that because we've got semantics. We've got, remember, these all came from different systems. Well, actually, we've got a semantic harmonization issue because in one system, we might have the Louisville Distribution Center, but in the other system, we call it Leiden Technology Center. So now we've got a semantic issue of being able to join these things up because, and in the container data, the IoT stuff, actually, we've got a delivery note, I think. Right? So semantically, they're the same, but they're not the same in the data. The destination is the same as the receiving plant, depending on which side of the problem you come from. Semantic issue, we need context. Is it a blouse, a turtleneck, or a tee? Well, it's the same, sorry. We have to semantically put these things together. We've got the shipper is the same as the container, right? This is all data mudging that has to go on. It's very unelegant, but actually if you want to ship and you want to do analytics over the whole journey of this little packet of aspirin, all of this stuff has to be sorted out, right, if you want to see it all in whole, or you have to get a lot of humans involved, right, etc. And then we can start to see and interestingly analyze. I mean, this is, we're now going, I'm going to draw it short in 5 minutes, give you time for some questions. I'm looking now at the different form. I want to see who the shipper is. I can now, this is the knowledge model of the system that's driving this, put together by the business users at the organization that's doing this, right? This logistics carrier company is UPS SCS. They're used by all those lanes, right? If I want to look at that specific lane, I can see that it's a polyurethane shipper. It goes by road. It goes off to two different has destination and an origin. If I want to go and look at that, I can cube my knowledge so I can see, I can transfer my information, my authoritative context, right? The same context that the machine is using to deliver, learn and deliver. I can also, as a human, validate that it's correct, and I can use it for discovery, and then I can see, right? I can see that Louisville is the locator has all of these different lanes. So when I am starting to go and say, well, actually, I'm producing a new drug in this factory, are there any lanes there that I can use that are already open, but with the same temperature guidance and all that stuff? I don't need to reinvent a new one. Stuff like that. And then I can start to put business intelligence on top using the data, right? So what I've tried to show you very quickly, and we've got 5 minutes for questions, you know, it starts off as a simple problem. I, as a business, cannot see how my packet of aspirin is moving through the supply chain because I've got all these different systems, and I've got one particular point in the data that isn't data. It needs coding. Now I need can I have an analytics dashboard where I can start to ask questions like, are there any lanes I can use? Has there been change of regulations that I need to change my operating procedures? Right? It becomes a very good use of data created from AI in combination with humans, right, who are putting in the knowledge with the AI doing the grunt heavy lifting of repetitive metadata markup, right, in order to give an answer that they believe gives them good business value, which is what we're all about. Thank you. If you want to get hold of me. 5 minutes for questions if you have any. Otherwise, I know lunch is served.
I will, yeah, there's a question there.
What's the most effective
you need a place to put the metadata. So if you're a search engine, your index has metadata in it, but probably, for example, for a search engine, there's an index of metadata in it, but that metadata is inconsistently applied. So we're a metadata maker. So we need to we give us the document, we'll look at it, we'll give you the 10,000 facts that are in that document. Those facts need to go back into something. So it could go back into a search engine index. It could go back into the content management system that start where the document started. It could go into a post-relational data store like, I don't know, Jenna or Smartlogic, which is a graph database. It goes into the graph where the ontology drives. It's very specific to the use case. But the metadata is created by us and given back to the system that needs it. So if you're a machine learning system, you're giving it a control set with additional metadata. And then the machine learning has got both its ability to learn and, if you like, some rigorously typed data that has come from your authority structure known as an ontology or taxonomy. That's it, thank you. If that answers the question. Getting there? Come to the socials and we'll talk some more.
Apparently wine helps you when you're trying
Wine.
to understand.
Wine hurts to a certain extent.
I've actually found that helpful in many different circumstances.
And
another
many of my team are here, so you don't just need to talk to me, you can talk to them. And if you want to get into polynomial mathematics of AI engines, you can talk to this guy.
So I'm not
but apart from that, we'll talk about wine, something
I'm
like
not seeing any more questions. So thank you very much, Jeremy, for coming and the presentation.